Somebody wanted me to talk about number 2 from the energy sheet. Yes? So 2 says, how much elevation will the car in the previous problem gain on the hill if it loses 150,000 joules of energy to friction on the way up? So problem 2 was a car coasting up a hill, right? And so this car is going along like this, and it's going to go up a hill, and it's going to roll up the hill. Well, what's its velocity going to be at the top of the hill? 0. So at the highest point it gets to, its velocity is going to be 0, because why is it going to be 0? Because if it's not 0, it's not its highest point, right? Okay. So basically down here we've got kinetic energy, right? When the car is moving, we've got 1/2 mv squared, right? And in problem 2, it all turns into mgh, right? I'm sorry, in problem 1, it all turns into mgh, and that's how you solve it. It's kinetic turns into potential, right? And in problem 2, we lose 150,000 joules of heat or joules to friction or heat or something like that. And so there's 2 ways to do this. Some people like to say that it's the kinetic minus 150,000, right? Some people like to say the kinetic turns into potential plus 150,000, right? So I'm gonna weigh in on the idea of making everything positive, right? So that's where the kinetic goes. It goes to, some of it's to potential, some of it is wasted, yeah, kind of a thing, right? This is number 2, right? So now we can just plug in our numbers: 1/2 1250, 20 times 23 squared equals 1250. 9.81. H is what we don't know, plus 150,000. Right? That comes from the problem. It says if it loses 150,000 joules. Right? Are we all good? That works. If you prefer, I mean, there's really nothing wrong if you secretly subtract 150,000 from this side and then figure it out. That's just fine too, right? Gets that. It gets the loss in there. All right.